Hello, everybody, and welcome to another science lesson with Mr. Carey or Mr. C. Today, I'm going to be working on first grade science. However, anybody is welcome to do this from the ages of kindergarten to, well, whatever. I don't care. Today's going to be an energy lab, and we're going to be discussing light and energy, and it's going to be really cool, and I call this glowing bright. So let's take a look at our materials that we're going to need for this build. All right, everybody, and here are the materials we are going to need for our glowing bright lab. First thing you're going to need is some ice cold water. Ice cubes are fine. You can leave it in the freezer for an hour or so. Quickest way, obviously, water and ice cubes. Second thing you're going to need is going to be hot water. Now, please don't use boiling water. Hot water out of the tap is fine if you have a hot water kettle. You don't want to get it too hot because what that is going to do is, one, if you're using a plastic bottle, could melt the bottle. And also, you're going to be putting the glow sticks in the water, and the hot water could melt the glue, and then the stuff in the glow sticks leaks everywhere, and then you got a big mess. You're going to need 3 glow sticks. I would recommend getting 3 of the same color. That way you know the differences between the 3 as we do our lab. And then you're going to need 2 containers. Small water bottles work. If you have 2 glasses, that's going to work as well because you're going to be able to see them. You'll see the glow sticks through them. All right, once you've gathered your materials, meet me over at the lab. Hey everybody, welcome back to another science lesson with Mr. Carey, otherwise known as Mr. C. And I have a guest here on the show with me, and this is Mr. Vance Walker.
Yes.
Vance.
Pleasure to be here.
Hey, great to have you here, Vance. So I cannot do this by myself. I definitely need some help here. So today is going to be our first grade science lesson. So if you like this, hey, stand by. I have a special guest coming for my second grade lesson. I'm not going to tell you who it is. It's a surprise guest. So without further ado, let's get our materials out. We have our 3 containers. You know what? Since this episode is called Glowing Bright, let's just show them. Go ahead and crack one of those things for me, please. Ooh, don't forget your glow sticks. Now, we went with the same color, blue, because blue shines pretty bright, and we're going to see some pretty dramatic results with this. So, this is one extra we have here, so don't break them yet. We have 3 glow sticks. Make sure you have your materials. Can you go ahead and turn the light on for me there, Mr. Walker? Thank you. Outstanding. Okay, don't forget your 3 containers. So we went here, and we have mason jars, pretty easy to see. Now we filled one with some ice water. This one's going to be empty, and this one's going to have hot water in it. Now, I brought a temperature gauge with me. You don't need to have it. If you have a temperature or thermometer gauge, feel free. You can kind of measure the water that way. So let's take a look and see what our temperature is for our, ooh, that's pretty cold, right?
Wow.
All right, that's gonna be pretty cold, so let's take a look here. And it says the current temp, I don't even think it's reading it, it's so cold. Yeah, right now it says nothing, so that's pretty cold.
That's how cold it is.
Yeah, if you wanna see it, it says, yeah, nothing, right? That's pretty cold, all right? Yeah, that's cold. So that's going to be good. Next, we have our hot water here. And let's go ahead. Is that pretty hot?
That is hot.
Okay, so I used my tea kettle.
Sure is hot.
And I also put it in the microwave a little bit. And let's go and see if that warms up a little bit. And let's switch turn that on. Perfect. And let's go ahead and check it out. Now, it takes a little bit for it to warm up. This should be at around 125, 130 degrees. You don't want anything hotter than that, and that's okay. All right, here we go. And yeah, it's about About 150.
Yeah.
Yeah, 150. All right, that's pretty good. So now what we're going to do is go ahead. I'm going to put this down here. All right, go ahead, and I'm going to pour the hot water. Now, if you are doing this, make sure you have
a supervisor.
A supervisor, a parent, an aunt, an aunt. That's like a cross between an aunt and an uncle.
Yeah, like what?
Yeah, so an aunt and uncle, a brother, sister, older brother, sister, please. Barber, hairstylist, guardian, babysitter, the mailman, right? If he comes in,
I mean,
have him help out, right? Mailmen, yeah, maybe they like science too. All right, so we're gonna go ahead and pour that in.
It's pretty hot.
That's pretty hot, right?
That is
now, we're gonna do this, and this is gonna take. Go ahead and let go. We're gonna put this right here, and now this lab is going to take about 3 to 4 minutes, right, to wait for your results. So first thing we have is our control. Now, a control, I've told first graders this before, because we've done this with plants. Control is just something you know that's going to happen. You already know the results are going to be, I guess, normal, right? So if I crack this, and I'm going to crack one. I like to crack one, too. Yeah. I'm going to crack one, right?
It's blue.
Shake it up, and it's blue. And I'm going to put it in my empty container. So that's my control, because I know how a glow stick reacts in the air, right? Go ahead and crack that one for me there, Vance. Cool, go ahead and shake it up. And now Mr. Walker's gonna go to put that in the ice water. And we're gonna put it in there. And then Mr. Walker, go ahead and crack the other one. And then we're gonna shake it up. And then we're gonna go and put it in our hot water. Ooh, that's hot, right? And now, we're gonna turn off the lights. But what I want you to do, you're gonna wait 3 minutes. 3 minutes.
3 minutos.
3 minutos. 3 minutes, and then we're going to check back and we're going to check out the results of our experiment. All right? I'll see you in 3 minutes. All right, folks. Good 3-minute break. We're back. And oh my goodness.
What a difference.
What a difference. What is going on here? Well, we put in... Now, I don't know why it's flickering. I can see on the camera it's flickering. It's not really supposed to do that. I think that's just the water, like the diffraction. But when we cracked them, they were all the same brightness, right? They were all, right? I mean, those are pretty much the same.
They're similar. Pretty good.
Vance, what did you notice first about the one in the ice cold water? What did you notice about that?
So when I first walked into this kitchen, I noticed that it was
you mean the lab, right?
The lab.
Sorry, the lab.
I'm
yes.
sorry. I'm so sorry.
Yeah, it's not the kitchen. This is our chemistry, science, physics, nuclear material lab.
There's stuff.
We've got all kind. You only want to look over there. Anyway, you walked into the lab.
Walked into the lab. Noticed this. I noticed it was a lot dimmer than both of these.
Interesting. So this one's dimmer than this one, but what do you notice about this one?
I knew that one got a little bit brighter.
I mean, this one's like super bright. I mean, it's kind of hard to, but I mean...
Look, that one's a lot brighter than that one.
And what I'm going to do, I'm going to hold them up for you so the viewers at home...
Don't you see that?
But you can see how dim this is.
Difference.
And the camera's probably not doing it justice, but dimmest, regular, and then really bright. All right, now... Yeah, that's really cool. But, Mr. Carey, why is it doing that?
Ooh, that's cold.
That's cold, right? Well, here's what happens. If you've ever looked inside a glow stick is just two chemicals together, okay? If you ever cut one open, which I have, there's two chemicals and there's a little glass vial, like a little glass container in there. That's why when it breaks. Those two chemicals mix together.
They release and then they're drawn together, and then that makes the chemical of making it glow.
Right, and so this is a release of energy, right? Energy can be heat, as in hot water, or it can be as in really bright. Okay, so this is a release of energy. Now, in cold water, in really cold water, right, the energy slows down, right? That's pretty much what temperature is. Temperature is just energy, right? The colder something gets, the small or the less the atoms are bouncing around, the slower they go, which is why it's dim. Now, Vance, what can you tell me about that? If that's true for the cold water, then what's the hot water making the glow sticks do?
So the hot water makes the glow sticks. So the hot water transfers more energy to the glow stick, so the atoms can bounce around instead of having to freeze like these atoms froze.
Well, they didn't really
didn't freeze, but they
went
go
slower,
a lot
right?
slower.
So if they go slower in cold water, what do you think they're doing in hot water?
They're going a lot faster because there's
Right.
more energy in the hot water than in the cold water. And
Outstanding.
Yes.
Outstanding. So yes, I mean, again, temperature is just energy. So the hot water is forcing this reaction, this chemical reaction, to go a lot faster, which means it's a lot brighter.
And then the chemical reaction is forcing this one to go a lot slower.
Now I've heard this when I was younger. You can put a glow stick in the freezer and it will last a lot longer. Now, based on that, why do you think? Which one of these glow sticks do you think will last the longest?
Comment below.
Comment below. Which one do you? And that's going to be your homework for if you're a first grader or a kindergartner or third grader. This is really a first grade lesson, but hey, anyone at my school, feel free, tune in, comment below. Based on what we told you, right? This slows down the chemical reaction, so it's a lot dimmer. The hot water speeds it up, so it's a lot brighter. So based on that, what do we think, which one of these is going to last the longest? Is it cold water lasts the longest? I mean, you can continue to see the light. Is it good old regular control? Or is it going to be my hot water? Comment below, which one do you think is going to last the longest?
I personally think it's
Don't tell him. Don't tell him.
Okay.
Don't tell him. Because I don't want everyone agreeing with what you said, and they're going to agree with what I said, and then we want them to comment below, and then maybe we'll do a follow-up video after this, telling our predictions. What do you think about that?
Yeah.
I think that'd be good. Okay. Again, this is Mr. Carey, Mr. Vance Walker. Mr. Walker, always a pleasure having you on the show. Thank you so much. You okay over there?
Yep.
You just hungry?
Yeah.
Yeah, it is lunchtime,
I'm
isn't
starving.
it? I'm starving too. I thought you were Vance Walker, not starving. Anyway, tune in. We've got second grade science. We're going to be recording that next, and that's going to be a lot of fun. You're going to drink that? You can. It's not again, the chemicals aren't in here. When you now, safety. If you do decide to break open the glow sticks, please don't drink them. Don't put them in your skin.
Do not.
Don't touch them. Right.
You can drink the water plainly, but just don't.
Yeah, I can drink the water in here because there's no chemicals in there.
You can drink the water in here
Because there's no water in there. Okay, that's all for now. First grade science, glowing bright energy lab. Stay tuned. Second grade science is coming up.